Rational exponents. This means that you are looking at something like the square root of 26. Well, when you have a square root or a cube root or any root, you can look at this in terms of a rational exponent as well. So the square root, that would also look like 26 to the 1/2 power. So when you have the nth root of a to the m, you can rewrite that as a to the m over n power. So the square root of t to the second, well, this would be an understood 2 right here if there's no other value. So that's going to go to t to the 2 over 2, which is just t. The sixth root of y to the 5th times the cube root of y to the second, well, that's going to go to y to the 5/6 times y to the 2/3. And then you can add your exponents. If we add our exponents, we can get a common denominator, which would look like 5/6 plus 4/6 when we simplify this, which would look like 9/6, which will give us 3/2. If you have the cube root of, let's say, k to the 5th over the cube root of k to the 7th, you can change that to k to the 5/3 over k to the 7/3. You can subtract your exponents. There were more in the bottom to begin with, so 1 over k to the 2/3. So when you have a square root, you can also look at that as a fractional exponent. Let's try a few more. If you're going the other way, if you have 121 to the 1/2 power, then that means that you're looking at the square root of 121. And we know the square root of 121, that goes to 11. If you have 64 to the 3/2 power, then that means you're looking at the square root of 64 cubed, which would look like 64 times the square root of 64, which would look like 64 times 8, and that is 512. If you have 81 to the negative 3/2 power, well, negative exponent, that means that it needs to go to the denominator. So that would look like 1 over square root of 81 cubed. Well, that's going to look like 1 over 81 times the square root of 81. So that looks like 1 over 81 times 9, or 1 over 729. If you have r to the negative 8 over 9 times r to the 17 over 9, there's a couple ways you could go about this one. You could switch the negative exponent to the denominator, or when you're multiplying, you know that you add your exponents. So you could look at negative 8 over 9 plus 17 over 9, and negative 8 over 9 plus 17 over 9 gives you 9 over 9, which is 1. So this will simplify to r to the first. If you have z to the 3/4 over z to the 5/4 times z to the negative 2, well, we could look at moving that negative 2 right here, or we can simplify. In the denominator, we are looking at adding our exponents, so we would have 3/4 plus negative 2. If I need a common denominator, that would look like 3/4 plus, I need a denominator of fourths, so negative 8/4. Oops, it was 5/4. Let's fix that. See, from right here, that's a 5. There we go. So now we have 5/4 plus negative 8/4, which gives us negative 3/4. So our numerator would be 3/4, so we have z to the 3/4. Our denominator would be z to the negative 3/4. So if we simplify that down, we would have 3/4 minus negative 3/4, which will give us 6/4, which will give us 3/2. So this whole thing simplifies to z to the 3/2. Let's try again. Here we have a power of a power, so let's simplify that by multiplying our exponents. This gives us p to the 3/4. Here we have a power of a power, so let's simplify that by multiplying our exponents. So that's going to give us p to the 10/4. Yes, you can simplify 10/4, but I'm going to hold off simplifying because right now I have 3/4 from the numerator minus 10/4 in the denominator, and I have a common denominator, and that will give us 7/4. Now we have right here, we have 3/4 minus 10/4. This is going to give us negative 7/4. That means it's going to give us 7/4. We have the negative, so it's left in the denominator. So this looks like p to the 7/4 like this. Let's try one more. We have z to the 5/8 times 3z to the 5/8 plus 5z to the 11/8. So now we need to distribute our z to the 5/8 the whole way through. If we do that, that means that we are looking at multiplying, so add your exponents. So that's going to give us 3z 5/8 plus 5/8 gives us 10/8 plus z to the 5/8 times 5z to the 11/8 gives us 5 plus 11 is 16/8. Again, you could simplify those fractions. I'm just going to hold off because now I have something that I can look at. But wait a second, if we look at this closely, 3z, 5z, I can't do anything with those. So I cannot combine these. If it was just z and just z, then we could look at doing further steps. But in this case, we have 3z and an exponent, 5z and an exponent. I don't have any like terms here. So all I can do is simplify. So 3z to the 5/4 plus 5z to the 2nd.